set theory. So what is set theory? All the math you learn is a set theory. Okay. And of course, it's also very important for computer science because later you will study something called what is a Turing machine, maybe next year or next year. It's a set with 7 stuff, and if 7 stuff, all the things are true, then this is a computer. And you describe it using set theory. So there are actually more than 2 types of set theory. I just said 2 because I don't want to confuse you. The basic one is called naive set theory. It's basically invented by a German guy called Cantor. And the other set theory is this Zamro-Frankel set theory. This is the ZF. And together with the axiom of choice, which is the cover, which have a long sentence which we don't know what the heck is going on, we call it ZFC. And basically this is the foundation of mathematics. And why we have 2 set theory? This is history. 1901, Cantor invented naive set theory. So what is naive set theory? It said that we just name something as a collection of stuff, and then this is a set. And later on, Russell found that no, there are some sets cannot be defined. For example, this cannot be a set. So I have a stuff X, and this X is a set. And if I have a stuff X that defined as any set that do not contain itself, the collection of this stuff, I call it A. The question is A belong to A? It turns out this becomes an if and only if. That means what? If this is true, this is true. If this is true and this is true, don't forget this means left implies right and right implies left. And this is contradiction. Why? Because you can only have true or false for a proposition. So this is not a proposition. This is something crazy. And this paradox makes Cantor feel sad, and then he entered a mental hospital and died there. So be careful, don't study math too much. And these 2 guys want to save Cantor's set theory. So later on, he talked to Russell, said that no, you are wrong. If we define set like blah 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 blah, then your paradox do not exist. So this is the reason why there's this set theory. Basically, they try to fix the error caused by this funny thing. And now what is set? A set is just a bunch of stuff. And here's the thing, this is not a definition. The real definition of set is the 8 sentence given by these 2 guys, which is some crazy thing. We don't talk about them in this module. Let's assume what is set. Set is just a bunch of stuff. That's it. And be aware that there are some stuff cannot be a set. That's it. Okay? And we will never touch those things. These are some examples. I just give you, this guy cannot be a set, right? This guy cannot be a set. So I have a bunch of stuff that X is equal X. This is not a set. Also, later we will learn what the heck is this. This is also not a set. Okay? Then what about the thing that is a set? All the students enrolled in this module is a set. All the students now in this room is a set. All the students here and like my teaching is also a set. And we can see that these 3 sets have different relationships. There exists somebody enrolled in this module but not present in this classroom right now, right? So this set is a bigger set than this set. So we say that the set below is a subset of the first set. So let's say I name this 3 set A, B, C. We will say that B is a subset of A. You can think of this symbol like smaller than, okay? C is also a subset of B, so I will write this, okay? So therefore, if C is a subset of B, naturally you will think that C is also a subset of A. This is transitivity, okay? So these 3 are examples of sets. And how do we write stuff? We write, if A is inside A, then we write this symbol, okay? Negation of this, we don't want to write this. This looks so ugly, so we just write this, okay? Otherwise, if you write this, you have to say A is not in A, and you always have to write so many additional symbols. Why don't you just write this? The same thing, 5 is not equal to 7. Actually, you write this. Who write that? Why not just this? So now you understand, this line in math have a meaning. This line means not, okay? And also, you have this. This is the same as you have something, bracket, and bunch of stuff, okay? So this line have a meaning, okay? So now, using this, we can now define what is set. For example, AIOU, I just write a brace bracket. Some people are too lazy to write this brace bracket and they just write a bracket. That's totally fine. In fact, in vector, we just write bracket. We never write this. Okay, maybe you don't know how to write this. Now it's time to practice. So it's like this and then, yeah. Okay, practice how to write this. Because usually students writing on this is extremely ugly. I understand. So practice how to write this, okay? And then you write this thing, x is an integer, x larger than 0. Then they define a set B, which what? It has a meaning of this big chunk of English word. As I told you, mathematicians are lazy. They just write P and then equal to a bunch of stuff. That's the way. If you want to talk about these I write this is better, okay? And then now here's an example. Suppose I have x squared minus 3x plus 2 equals 0. And the definition is the solution of this thing. Then let's say I know the solution is 1, 2. Then I just write S1 is 1, 2. It contains two things, like AELU. I write down explicitly the member. Or let's say you don't know how to solve this. Suppose you don't know how to solve this. Then you just say x dot dot this thing. What is this dot dot? It's not normal dot dot, it's a special dot dot. It means such that. Okay? That means what? That means x dot dot phi x means I have a set S defined as all the stuff x such that this proposition is true. Now you see why we study logic before set, because this thing inside actually is a proposition. Okay? And again, what about the comma here? The comma here is not a simple comma. This is and. This is the logic and. That means in this case, we have two propositions and there's an and. So basically, the idea about set theory is that you have a set, you have a something such that this is true, and so on until you finish, and all of them is and. That's it. Okay? Now let's look at some basic set. The first one is called natural number, 0, 1, 2, 3, 4, 5. Here's the thing. Mathematicians, some of them start with 1. Computer science start with 0. You belong to computer science, so you have to start with 0. Don't argue with me, start with 1. And what is integer? Integer is just this thing, you add a minus sign. So it's the same thing. Of course, you may wonder why this integer start with Z is German, okay? Rational number, you just write this. Basically, you have a fraction, and the stuff inside the fraction are integer. That means what? I can have negative 1 over 3. Okay, I didn't write. What is R? R is all the rational number and irrational number. That means including this. And then C is complex number. That means now you allow this square with negative 1. Okay, now here's the funny thing. What the heck is this H? You probably don't know. If you study robotics in the third year, then you probably to handle something like this arm have to turn this, and then this, and then this, and then something like this. How do you describe the geometry of this? You can try to use a vector x, y, z and then to describe this, but I can tell you, if you use x, y, z to describe this kind of 3D motion, you will die because the math will be insane. But if you allow this funny thing, a plus bi plus cj plus dk, where ijk product equal -1, which is some funny thing, this is called quaternion. And then what about these two things? Oh, this is a so-called special linear group, which is all the set of 2 by 2 matrix with determinant 1. At this moment, you suppose don't know what the heck is this, doesn't matter. And what about this? It's all the matrix with inverse. At this moment, you supposedly don't know what the heck it is, so it doesn't matter. So you should know it's N, Z, Q, R. In this module, we don't touch C, and that's it. So we just touch everything up to here. But why I mention C? Because C is very useful. Forget about all the integration about sine cosine you learn in high school. If we use Euler formula, integration of all the sine cosine become very simple. And then everything here, you can ignore it, okay? I just let you know. And then what's next? What is a subset? This is the definition of subset. Subset means A is a subset of B if anything X inside A implies X in B is true. So this is the idea. So, suppose I have a set A, bracket B, bracket ABC, bracket D. Is A in S? Yes, here. Is B in S? No. B is not bracket B because this is a set. You cannot say B is a set. B is something, okay? Is this guy in S? Yeah, here. Is this guy in set S? Yes, here. Is AB in set S? No. You have AB bracket, but this is AB inside one bracket. You don't have that. Is D in S? No. This is bracket D. If B is not equal to bracket B, then of course D is not equal to bracket D because D is an element or a stuff. This is our set. This actually is a set of set. So bracket is a set, right? So now I have a bracket of bracket. That means set of set. And then this S is actually set of set for D. So D, bracket D, and bracket D are different things. This is an element, an object. This is a set. This is a set of set. It's different thing.